In this lesson, we are going to be looking at graphing polynomial functions. So our goal will predict the end behavior of polynomial functions by interpreting the leading coefficients and degrees, identify turning points, relative maximum, and relative minimum. And then we'll also look at calculating the average rate of change. So first, standard form. Standard form shows any like terms combined and the terms by degree in descending order. Okay, so you have to make sure you combine any like terms and go in order from highest to lowest for your degree. So starting with the highest one and then going down all the way to your constant. Then our leading coefficient refers to the non-zero factor that is multiplied by the greatest power of x. So our first number, when we write it in standard form, or our first term, I should say, that coefficient, the number in front of that term, is going to be your leading coefficient. And then the last thing, the degree of a polynomial is the greatest degree of any of the terms. Okay, so standard form, writing your polynomial in descending order from highest to lowest power. Leading coefficient is the number in front of your greatest power of x, and then your degree is the greatest degree of any of the terms. Okay, so in example 1, we are going to classify polynomials. So we are going to write each polynomial in standard form, identify the leading coefficient, the degree, and the number of terms in the polynomial. So standard form, again, you're writing the degree in descending order. So for A, I have negative 4x plus 9 plus 2x cubed. So I want to look for my highest power first. My highest power is that x cubed. So 2x cubed will come first. Next power would just be x, so minus 4x, and then plus 4. My leading coefficient is the number in front of my first term, so that's going to be 2. My degree is my highest power. My highest power here is 3. And then I need to count the number of terms I have. So I just need to count how many terms there are. So 1, 2, 3. So there's 3 terms. Terms are separated by addition and subtraction signs. B, I have 2x minus 3x to the 4th plus 6 minus 5x cubed. So I'm going to go ahead and write it in standard form. My highest power is x to the 4th, so I'm going to have negative 3x to the 4th first, minus 5x cubed plus 2x plus 6. Now make sure you're keeping the sign when you write these in standard form. Now I'm going to go look for my leading coefficient. My leading coefficient is the number in front of my greatest power of x, so that's going to be my first term here. So that's negative 3. My degree is the highest power. My highest power is 4. And then my number of terms, I have 1, 2, 3, 4. So there are 4 terms in this problem. Okay. There is a try it problem C for you to do. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So for C, I have x to the 5th plus 2x to the 6th minus 3x to the 4th minus 8 plus 4x to the 3rd. So I'm going to write it in standard form. My highest power is x to the 6th, so I'm going to have 2x to the 6th, then plus x to the 5th minus 3x to the 4th plus 4x cubed minus 8x. A good tip when you are doing this, if you want to cross off the terms that you have used, so you don't make sure you don't miss any, you can definitely do that. So if I would go through, I started with 2x to the 6th, mark it off, and then x to the 5th, negative 3x to the 4th, 4x cubed, minus 8x. So then you see that you didn't miss any terms when you wrote it in standard form. Leading coefficient is my number in my first term, so that's going to be 2. My degree is the highest power, so my degree is 6. And then the number of terms, I have 1, 2, 3, 4, 5 terms in this polynomial. So now we're going to continue on. We're going to start looking at end behavior. So the end behavior of a graph describes what happens to the function, what function values as x approaches positive and negative infinity. End behavior depends on the degree of the polynomial and the sign of its leading coefficient. So this table below is going to help us organize the different end behaviors of polynomials. So at the top, you'll see that it says even degree and odd degree. On the left-hand side, we will have positive leading coefficient and negative leading coefficient. So you need to look at your degree, whether it's even or odd, and your leading coefficient, whether it's positive or negative, to determine how the ends of your graph are going to look. So for even, we'll start by looking at even. Even will always have your end behaviors go in the same direction. So for even positive, both of them are going to go up. Okay, so the left side and the right side of the graph will end up going upwards. So as x goes to negative infinity, as it goes to the left, my y value is going to keep getting bigger and bigger and bigger, so it's going to go towards positive infinity. As x goes to infinity, which is to the right, y is going to keep getting bigger and bigger and bigger and go towards positive infinity. Now for even degree, negative leading coefficient, same direction again, except this time they're going to be both going downwards. Okay, when they both go downwards, they're heading towards negative infinity on both ends. Okay, odd degree, for odd degree, they are going to have opposite directions. For odd degree, positive leading coefficient, the left side of your graph is going to go down, the right side of your graph is going to go up. So as x goes to negative infinity on the left, okay, going towards the left, your y value is going to keep getting smaller and smaller, go towards negative infinity. As x goes to infinity, goes towards the right, y gets bigger and bigger and goes towards positive infinity. The last situation, odd degree, negative leading coefficient, my first direction is going to be going up, the other one down. So on the left side, your graph is going to get bigger. Y will go towards positive infinity. On the right, your y value is going to get smaller and smaller, go towards negative infinity. So on the next page, we are going to use these end behaviors to identify what's happening in graphs. And then we'll also look at equations and identify the end behavior based on an equation. So in example 2, we are going to understand end behavior of polynomial functions. So we're going to determine if a function is odd or even and determine the number of zeros. Zeros are when it crosses the x-axis. Okay, so zeros cross the x-axis. Okay, and remember that's your horizontal axis. So for A, before we start A, odd or even. Okay, odd means they're going to be opposite directions. Even means the endpoints are going to the same direction. So for A, if you're looking at your endpoints here, these guys, they are both pointing downwards. Okay, they're both pointing down. So since they're both pointing down, they're pointing in the same direction. These guys are going to be even. Then I'm going to look at my x-axis. Okay, my function does not cross my x-axis at all. So the number of zeros I'm going to have is 0. Looking at B, okay, my left-hand side is going up. My right-hand side is going down. So my end behaviors look like this. Okay, they are opposite directions, so they are going to be odd. Then looking where my graph crosses the x-axis, it crosses right here, here, and here. So 3 times. So there are going to be 3 zeros. For C, okay, on the left-hand side, my graph is going up. Right-hand side, my graph is going up. So the end behaviors would look like this. They are going in the same direction, so that is going to be even. Okay, and then the number of zeros, looking where it crosses the x-axis, it crosses here and here. So 2 places, so 2 zeros. There are 3 try-it problems for you to do. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So for D, my left-hand side's going up, right-hand side is going down. So my end behaviors look like this. They are opposite directions. That means it is going to be odd. My graph crosses at 3 different points, so I have 3 zeros. It crosses the x-axis at 3 different points. For E, my left side's going down, right side is going down. So my end behavior looks like this. They're going in the same direction, so that is going to be even. Then looking for my zeros, it crosses 1, 2, 3, 4 times, so I have 4 zeros. My last graph, left-hand side's going down, right-hand side's going up. So my end behavior looks like this. They are opposite directions, so that is going to be odd. My graph crosses 1 time, so I'm going to have 1 zero. So now we're going to go ahead and look at polynomial functions, the actual equation. Example 3, we're going to understand end behavior of polynomial functions. We are going to identify the degree and leading coefficient and then describe the end behavior of each graph. So you have to make sure also your equation is in standard form first. That'll make it easier for you to identify your degree and leading coefficient. So for A, I have h of x equals 2x to the 5th minus x squared minus x minus 2. It's in descending order, so already in standard form. So I'm going to go ahead and identify my degree. My degree, number in front. Oops, that's not a highlighter. My number in front is 2, so that's going to be my degree. Or no, sorry. We're doing degree first, not leading coefficient. I apologize. My degree is the highest power. My highest power here is 5, okay? So 5 is my degree. My leading coefficient is the number in front, so leading coefficient is 2. So looking at my degree, okay, my degree, is that even or odd? Okay, 5 is an odd number. And then looking at my leading coefficient, that is a positive number. Oops, sorry. Positive number. So since it's odd, and it is positive, my end behaviors look like this. So going to the left, I'm going downwards, so y goes to negative infinity. On the right-hand side, y is going to keep getting bigger and bigger, so it goes towards positive infinity. For B, I have negative 2x to the 6th minus x squared plus 2. I'm going to go ahead and look at my degree first. My degree is my highest power. Highest power here is 6. Leading coefficient, number in front, that's going to be negative 2. My degree is even. My leading coefficient, negative. So even means they're going in the same direction. So here, they're both going downwards. So that means my y values are going to go towards negative infinity. For F, for C, I have f of x equals negative 2 plus x squared plus 2x to the 6th. Now this is not in standard form, so I'm going to rewrite it in standard form. So 2x to the 6th plus x squared minus 2. My degree, 6. My leading coefficient, 2. So my degree, even. My leading coefficient, positive. So they're going in the same direction and they're both going up. Okay, so as x goes to negative infinity, y is going to get bigger and bigger and bigger, go towards positive infinity. As we go to the right, x goes to infinity, y gets bigger and bigger and bigger, goes towards positive infinity. For D, I have j of x equals x squared plus x plus 2 minus 2x to the 5th. I need to rewrite this one in standard form first. So highest power is the x to the 5th, so negative 2x to the 5th. Make sure you keep the sign. Plus x squared plus x plus 2. My degree is going to be 5. My leading coefficient, -2. So my degree is odd. My leading coefficient is negative, so they're going to be in opposite directions. Left-hand side, it'll go up. Right-hand side, it'll go down. So as x goes to -infinity, as it goes to the left, y gets bigger, so it goes to infinity. As x goes to the right, it goes to positive infinity, y gets smaller and smaller, goes towards negative infinity. On the next page, there are 2 try-it problems for you to do, E and F. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So for E, I have f of x equals 2x to the 6th minus x to the 5th plus 6x to the 4th minus x cubed plus 4x squared minus x plus 1. This is already in standard form, so I'm going to go ahead and identify my degree. My degree is 6. My leading coefficient is 2. Okay, so my degree is even. My leading coefficient, positive. So both end behaviors will point up. So as x goes to -infinity, y will go to infinity. As x goes to infinity, y goes to infinity. For f, I have g of x equals 8x plus 4 minus 5x cubed. This one I need to rewrite in standard form, which is -5x cubed plus 8x plus 4. My degree is going to be 3. My leading coefficient is going to be -5. So my degree is odd. My leading coefficient is negative. So my end behaviors, the first one will go up towards the left. On the right, it'll go down. So as x goes to -infinity, y goes to positive infinity. As x goes to infinity, y goes to negative infinity. So now we're going to go ahead and look at our last example, example 4. We're going to be looking at turning points, relative maximum, minimum, and average rate of change. So points where the function changes, well, where the function values change from increasing to decreasing or vice versa, are called turning points. So we can identify the number of turning points and also identify their coordinates. A point where the function has the least value over an interval is called a relative minimum. And a point where the function has the greatest value over an interval is called a relative maximum. So in these graphs below, we are going to identify key features. So we're going to look at turning points, zeros, relative maximum, relative minimum, average rate of change, and then we're also going to look at the end behaviors. So kind of combining some of the things that we've talked about already. So in the first graph, we are going to look for turning points. So turning points are where the graph changes from increasing to decreasing or decreasing to increasing. So looking at my graph on A, okay, I'm going to look for turning points. So turning points, again, where they're changing from increasing, decreasing, or vice versa. So one point would be right here, here, and here. So you're kind of looking at the middle of the curve. You see from this left-hand side, I'm starting to decrease, 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 and then at that point, I start to increase, okay? So we have 3 turning points. So I'm going to go ahead and label them, name their ordered pairs, and some of them you'll have to approximate a little bit. So that first one is -4.5, and then -0.5. My third coordinate, or second coordinate, sorry, not third yet. The second one is -3, 0. And then the third one is 0.5, comma, -8. Zeros are where it crosses the x-axis. So I have 1, 2, 3 zeros. And you can just list out those values. So the first one's -5. Second one, -3. Third one, 2. Okay. Relative maximum and minimum, you talk about your y values. So I am going to look for the highest value on my graph for my maximum. Okay, the highest point is going to be right here, and that is going to be y equals 0, so just 0. The lowest point on my graph is this guy right here, and that's at y equals -8. Now for average rate of change, you need to look at average rate of change from 0 to 2, and these are our x values. So x equals 0 and x equals 2. So I'm going to need to find those ordered pairs. So for when x equals 0, my ordered pair is right here. So that's going to be 0, -7. And then when x equals 2, my ordered pair is 2, 0. Between these 2 points, I'm going to go ahead and find my slope. So m equals 0 minus -7 over 2 minus 0. So 0 minus -7 becomes 7, 2 minus 0, 7. Okay, so your average rate of change will be 7 over 2. And you can leave that as a fraction. The last point is looking at our end behavior. Okay, if you look at your graphs, they are both going upwards. So your end behavior looks like this. So they're both heading towards positive infinity on both ends. For B, I'm going to go through the same process, look for my turning points, zeros, maximum, minimums, average rate of change, and my end behaviors. So starting with turning points, okay, that's where it's changing from increasing to decreasing or vice versa. So right here is one and right here. So there's 2 of them. So the first one is -4, 8. Second one is 0, 0, our origin. Now my zeros are where they cross the x-axis. So 1, 2, there's 2 of them. The first one's at -6. Second one is at 0. Now I'm looking at relative maximum or minimum. Maximum highest point, that's right here at y equals 8. Minimum lowest point is going to be here at 0. Now my average rate of change this time is from -4 to 0. Again, those are my x values, so x equals -4 and x equals 0. I need to go find those ordered pairs and find the slope between them. So for -4, for x equals -4, it's going to be this point right here. So that's -4, 8. At 0, my ordered pair is 0, 0. So to find my slope, I'm doing y2 minus y1 over x2 minus x1. So 0 minus 8 over 0 minus -4. 0 minus 8 is -8. 0 minus -4 is going to give me +4. -8 over 4 simplifies to -2. So my average rate of change is -2. End behavior, to the left, my graph is going down. To the right, my graph is going up. So my end behavior looks like this. As x goes to -infinity, to the left, y is going to get smaller, so that's going towards -infinity. As x goes to infinity, towards the right, y is getting bigger and bigger, goes towards positive infinity.